Welcome to the Unriveted podcast, where we talk about technology initiatives like digital transformation, artificial intelligence, and people. Today's podcast is brought to you by one of my favorite sponsors, Vespa Motorsports of San Diego. Thank you for kicking me in on the hat. And Beaniac Coffee, where I am now. Beam me up with lots of caffeine. John, we have a guest clearly. Would you like to do the honors with an intro?
All right, thanks, Martin. I will do just that. Today we are joined by Andrea Constantinof. I got that right. Constantinof, Director of AI and Data Science at OpenText in Toronto, Ontario, Canada. So thanks for joining us, Andrea. And I guess, to get things started, just give us a little introduction to yourself, a little walkthrough on your background, what led you to where you are today, and we'll take it from there and start peppering you with questions.
Sounds good. Thank you so much for the intro. So I have a pretty unconventional path to data science. I started about 5 years ago, and my path actually came, a little unconventionally. So I was really intimidated by math and computer science growing up. I thought, I'm not smart enough for this. It's, I'm not a coder. That's not for me. And I was really intimidated. So I went through undergrad and, like every good science student, I decided I wanted to be a doctor, an MD. And, you needed to have really good grades. So I wasn't going to take some computer science courses in undergrad because that could hurt my GPA and then I wouldn't get into med school. Turns out I didn't need computer science to hurt my GPA. First year calc to help me do that myself. So I found that tricky. But basically what I realized is that I really enjoyed research. And so I started volunteering in different labs and did everything from growing Huntington protein on gold and shooting electricity through the gold to measure the growth of the Huntington protein, to doing cognitive neuroscience research, where we measured the impacts of subarachnoid hemorrhage, which is small brain bleeds, on memory and cognition in humans, to work with animals, where I actually worked on addiction research and gave some rats some cocaine. So I've done a lot of research in my life, and it's all been very interesting and intriguing. So I've been really interested in that. And it's really when I started to do my master's where I realized that, we can only do so much with Excel spreadsheets, that we need to start coding and we need to get more sample sizes and we need to start doing population studies. And that's where I started to realize that, maybe coding isn't so hard. And I started getting books from the library and they all have little animals on them, which is very adorable and they make them less intimidating. And I started learning Perl. I installed a Linux operating system on my laptop and essentially wrecked my personal machine because I didn't know how to get Windows, and it was a whole thing. But I was really trying. And then when I started my my doctorate, that's where I really threw myself into it. So in my doctorate, I looked at how prenatal stress affects brain development using a guinea pig model. And we looked at it over multiple generations. Now, why guinea pigs? Because their gestation is the closest to humans from other rodents. Fun fact, it's a fun one at a bar. You can use it later. And so this is all good. And my colleague, when I entered the lab, my colleague had spent 6 years, breeding these guinea pigs to get 3 generations of these guinea pigs, 6 years of his life. And then I came in and I'm really good at the PCR technique. And now with COVID, everyone knows what PCR is. I'm very good at that. I'm very good with the pipette. I'm excellent at it. And so they brought me in to look at how the brain, like the genes in the brain, the expression had changed because of the prenatal stress. Mm-hmm. The issue is that the technique we were using to look at the gene expression, you could only look at how 1 or 2 genes were impacted. This guy spent 6 years of his life doing this, not to mention all the animals. What if I picked the wrong gene? Like that's a lot of pressure because you don't get a lot of you don't get many chances. And so I said, the technology exists to look at how every gene in the genome is impacted. Whole genome sequencing exists. Can we do that? And my supervisor said, yeah, but Andrew, no one in this lab knows how to analyze that kind of data. And I said, well, how hard could it be? Like, I'm sure I could Google it and figure it out. And so 3.5 years later, I Googled it and I figured it out. And that's really how I came into coding and I came into data science, not with the academic background, but through the just brute force of I need to solve this puzzle. There has to be a better way. And I'm going to figure out how to do that. And so it's very much been like an exploration, a scientific journey for me to do this and to solve it. And I've really fallen in love with solving puzzles. And it's no longer guinea pig brains. I now actually do a lot of work in retail that I really enjoy because it's the same idea, right? It's what are the relationships between different data points that lead to the increased probability or decreased probability of a desired outcome, and how can we increase the probability of that desired outcome? And typically in retail, it's how do we get you to purchase our product or more of it? So yeah, that's how I got here.
Well, you're in luck because both Martin and I have guinea pig brains. So this this is
Excellent. My
par for the course for you.
expertise.
Yeah, yeah. So you're in good shape, and I can relate somewhat, to your story because I'm also came from a self-taught background in data science and machine learning. I didn't go to school for it, and I definitely didn't get a PhD in it, or a PhD in general, I guess, like you did. And my background was always kind of in data and research. But I'm kind of interested from your perspective, since we have a self-taught, experience getting to where we have been today. Uh, how would you compare what you learned in your academic, brute force approach? That sounds like you just kind of, this is something I got to learn to solve a problem that I want to solve, and it's kind of blossomed into a career now. Uh, what would you say were some of the similar, we'll say differences, I guess, between the things that you learned in your own self education, and then when you went into the real world in your actual career experience? What are some of the things that you've seen in the real world that you say, "Oh, wow, they don't really teach that," or "That was something I never really learned. I had to learn that kind of trial by fire." Any examples that you can give us?
Oh yeah. So in academia, you can kind of bulldoze. Like you can just go, right? You don't really need to like you it's really good to collaborate, but if you need to go and get stuff done, you can go and do that. And if you bother somebody, if someone gets upset by it, it doesn't really matter because publications is king and scholarships are king, right? So the focus on relationship and community building is less strong. I think that's changing, but and the other piece was I people cared about the data and the proof was in the pudding, right? If you had an idea, you had to sell the idea, but usually you could do a smaller experiment to show a proof of concept. And then if there was a promise there, you could continue doing it. Um, what I didn't realize coming into corporate is how much emphasis on sales there was. It's not enough to have a good idea. You had to really sell it and across multiple different audiences and really get across why this is a benefit. And really get into a more like a measurement mind frame. I feel like in science we take that for granted, right? It's all about the p value. It's all about what
Mhm.
was did we hit statistical significance, which is also end all be all. And in corporate, it's why do I care about this?
Mhm.
Why are you doing this? I know how to do that. Why are you doing this? Well, no, it can be better. Well, no. So it's actually really interesting. And I think pre-COVID I was at a conference and they were saying that, the biggest impediment of data science, it isn't the math, right? It's actually people's perception. It's a lot of fear, it's a lot of uncertainty, it's a lot of, people worried about AI taking their jobs or uh not knowing, if there's biases in it, which is a real fear and a real concern. And so how do you communicate across all these different layers and get through all these different emotions and feelings and contexts and build something and really, bring it to a finish line, right? And think about all the things that it takes to build a model and to use it, right? It's not enough just to build a model and have it on my laptop, right? Someone has to use its recommendations. Like if we have a pricing model, we have to put that price on the shelf. Well, who's going to do that? If we're a brick and mortar store. I think one of my favorite, examples, this is when I first started working. I worked at a store called Canadian Tire, which, if you're not familiar with that, it's like a big retailer, where like a Walmart almost, but you can get your car service there as well. And it was a brick and mortar store. And they didn't have like centralized pricing. So we did an A/B test for our pricing model, and we had 500 stores participate, and people had to physically go in the aisles and change the pricing to be what our model said. And it luckily worked, or else it would have ended poorly. But it's very interesting. These are the types of steps that need to happen. So how do you get all these levels of executives, all these levels, all the way down to the person going across changing that price, on board to really bring your model to life? And we focus a lot on the math and the stats and the coding, but that's what brings a model to life. And that's what they don't teach you in school.
Yeah, the people, right, Martin?
The people over everything
right.
is key.
Well, kudos for your progression and insights, because those are actually real scenarios of when you're in academia, you don't see in how you apply it. And selling, well, every time you go to a job interview, you're putting on your sales hat. Every time you're meeting someone new, whether you're trying to exchange a good or service, you're effectively in a sales role. How do I either get myself out of this conversation quickly, or how do I engage to go somewhere more entertaining? And so those are skills that I think are best taught through socialization, which is a challenge in the technology world where everybody's an introvert in the corner facing forward, which was fun. Me being a software engineer back in the early days, and just, not with the punch cards, John, but actually typing on a keyboard and recording it actually to magnetic media, and then how we share that code. And we had to actually start a community of people sharing code. And I feel the scenario in data science is like stepping back and learning what SDLC is, software development lifecycle, and then this thing called the cloud. Oh, it's not my laptop. It's out there. It's somewhere else. And that has to be an eye opener too for you. What are your thoughts? You brought up a great point. How do I go from my laptop, and I have to make it implement live for something? What are your thoughts around that?
This is the other big piece so I learned data science. I learned how to code on my, my little Jupyter notebook, like every good data scientist does. And then you realize, yeah, it's not going to live here. And that's where, when I was actually working at Loblaw, a major grocery chain, that's where you get a really strong appreciation for the software engineering that goes into deploying a model. And, that's where I think a lot of data scientists, we have to really up our skills, because again, if I just make a model that nobody uses, if a tree falls in the woods and there's no one there, did it make a sound? Well, if I make a model that nobody uses, does it make any money? No. So so that's why we have to, okay, well, how do I share it? So, like we have to have our GitLab, we have to share, we have to have merge requests and set that up from the get-go, right? That has to be from the basis. We have, unit tests on our code. We have modularized code. It's functional programming. Yeah, you can do some discovery in a Jupyter notebook, but that can't be end state. And I think that's extremely important. And it's extremely short-sighted to not start developing in that way, because you lose a lot of momentum, right? It takes me a few weeks to build a model that's good enough, right? If you think about data science as an iterative process, I can spend years waiting for perfect, but I can make you something that's better than nothing and start showing you incremental value today. So let's do that. And if the business is okay with that, then it's going to go from this is great to how can we get this in use very quickly. And if we've not set ourselves up to follow that wave, we've lost a lot of momentum. If I show someone something, hey, do you like this? Yes. Okay, great. It's going to take us 6 months before we can actually use it. Like that's a hard message to sell. Guarantee they're going to figure out a way to do it on their own, and they're going to come up with some Excel solution that maybe does something good for them but isn't your solution, and it maybe isn't as good as your solution, right? So it's all about, because this is a sales piece, we can't lose momentum if we're able to get people on board. And part of that is thinking about software engineering best practices as we're doing data science so that we can be nimble and quick to delivery once we get the algorithm that's working.
Right, right. And I think you hit on something there too. A couple of things is that the quick wins is very important, especially at the initialization of a data science function within an organization, right? So if an organization has no experience in implementing a data science practice and the machine learning models that are the goal of the people in that practice, from what I've seen, it sounds like probably maybe from what you've seen too, is that a lot of times, and this is probably blown out of proportion just by what people read and hear on TV, hear on online or on TV, is they think that they're gonna uh, throw $10 million at this project and they're gonna get these amazing results the next day. And then when someone says, well, in order to get those results, it's going to take 6 months, they say, oh. And they don't think about all the stuff that comes, before that, like you said, like setting up like a proper development environment, and getting all of the pieces together. And that part alone can take, months, depending on the size of the operation. So, is that kind of in line with some of the experience that you've seen, people that are outside the sphere of data science and machine learning, is that the expectations of those people sometimes vary widely, for like how long it takes to achieve value that they expect? And is it a hard sell to say, hey, like we could potentially get to a 25% lift of sales of this particular product online in Europe or whatever, just throw an example out there. So when you have those conversations with people, do you see that it's typically, like you have to kind of lower those expectations and say, hey, we have to do this, and this, and then we'll slowly get to that point? Have you found that challenging with your clients and businesses you've worked with before?
Oh yeah, I mean everyone's everything yesterday, right? And like
Mm.
we're so used to, like, if I order something now, it can come later today. You know what I mean? Like, we're used to instant gratification. We're used to things coming, and we're used to, we're hearing in the media AI, LLMs, da da da. Like, there's a lot of buzz, and so it's really interesting to make sure people understand the expectations. It's also really interesting, um, how much people want to understand of the model. So for me, I'm all about very much transparency and trying to explain everything that I'm doing. Like if we're doing a neural network, I'm going to walk you through what that means and show you so that everyone can understand. And I almost feel like it's almost like we just showed you how the magic trick was done, and people almost get a little disappointed. They're like, "Oh no, like is it that simple?" Like there's a lot of money to be made with y equals mx plus b, right? And that almost disappoints people. And so sometimes they're disappointed with the results when they realize how simple it is. And so you then say like, "Oh, it's AI." And it's interesting because I've had mixed, I heard somewhere that the major consulting firms never say how the model is doing, right? Why it's doing that. They just talk about the results and what's important and these are the features, but they never go into what the actual algorithm is. And that's very much against my philosophy, which is, here it is, I want you to understand, let's question it together and let's do it. And it's so funny because I've been on calls with my business colleagues that they've bought my product, they've implemented my models and they understand it. And we're almost listening to a pitch from another team, and this team is using jargon, is this neural, they're not being clear at all. And I'll get pings from my business partners like, "Oh, this is so cool." And they're like, what is it? You don't even understand it. Yeah, but they're saying neural AI net, and like, what is that? Right? It sounds cool. So I think at a certain level, we all want the AI magic. We all want to still believe in magic and the spark of the unknown. And so some of us, like, we have to sell it that way, and we have to use all the jargon and get you excited about it. But then that leads to a lot of misunderstandings and a lot of misexpectations. But then if you come in and say, yeah, so like I did AY equals MX plus B, +3, and then it works, and here's my results, like that's less exciting. But have I sold it to you? So I'm still it's still a really interesting, I don't know, the jury's still out, but expectations versus reality versus value, I think is a really interesting paradigm that I'm still not cracked that nut yet.
You brought up one of the most important elements of math that I still use today, y equals mx plus b. And I've
Shockingly
developed so
effective.
many things with linear equations.
Yeah.
It's the kids take it for granted when you first learn it, but then when you start applying it or second orders of it, it's magic.
Yeah,
Yeah,
I agree. I agree. I've used that example. I mean, it's funny that you say that because I used to do, or I still, I guess, occasionally do training in ML in a variety of topics. And I can envision the slide in my head that says y equals mx plus b. When people are like, well, what's a machine learning model? I'm like, well, have you ever seen a equation for a linear model? And they're like, oh, yeah, I remember that. I'm like, well, in essence, that's about the simplest machine learning model, statistical model that you can have. And that's another thing I say too is the complexity of the model is not the important thing. Everyone wants to throw a neural network or an LLM, and like because it's the newest and biggest and most complicated, surely it must be the best. But you hit on that point of there's a trade-off between the value or there's a trade-off between the interpretability and the complexity of the model, and that one goes up, the other one goes down. But at the end of the day, and I think you hit on it earlier, was it doesn't, who cares what you're using? It could be linear regression, it could be logistic regression, it could be like a convolutional neural network. Obviously the use cases are going to differ for whatever you're trying to accomplish, but the business side doesn't really care about how fancy your model is, or at least they shouldn't. They just want to say, okay, here's what I was doing in the past, and it was earning me like this amount of money, and or losing me this amount of money or whatever. And here's what this model, I don't care what it is, but I went from here to here. And if that happens to be a linear regression model, wow, then so be it. And that's, obviously one of, if not the easiest model to explain. So I'm glad that you hit on that point, because I think a lot of people want to just go right into all the most complex, because that's where the action is, I guess. So
Well, the other thing I find really interesting is when the target outcome is the accuracy of the model. Like, we need to have 85% accurate.
right,
Why?
why?
How much does that make you? Like, that's it.
Mhm.
No, like the goal of a model isn't an accuracy percentage. The goal of the model is money, or like an
Mhm.
outcome, right? Accuracy is not an
Ooh,
outcome.
ooh, 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 ooh. I have to respectfully disrespect that comment with the following. You ready?
Go.
I am on a project with the model that must be judged by its accuracy because it's using the outcome inference to determine if someone is potentially under the influence of alcohol, a third party substance, or fatigue. And the model accuracy has some great metrics. However, 85% is not a good number when you're trying to tell people that. It's more, they want to hear 95%. They want to hear higher because we're talking about people's livelihood. So there's an example of where, and I'm not disagreeing about the financial part, but there's an example of where the inference accuracy has to be much, much higher than a low number. That it's not about money, it's about making the right choice.
That's fair. I'm in retail, so it's very much just like, but I think that's really like, so I think people get hung up on accuracy. Obviously there's context where accuracy is really important, and that's what you have to hit. Like if I have to diagnose cancer from images, accuracy is going to be really important, right? I mean, there's definitely going to be examples, but I think if that's the only number you have without context, I think every number needs context, and that's how numbers exist. They don't just like have a context by themselves. They just are numbers. So I think that's what folks need to understand is like, what's the current accuracy of our current process, right? And how does 1% improvement on that, what's the benefit of that? How does that actually benefit us? And because you get into this cycle where, you know, is the juice worth the squeeze? If I have a model that's 85% accurate, what's the value of bringing it to 90%? Like in your case, Martin, huge, right? We need it to be 99% accurate because it impacts people's lives. So every percentage is going to make a difference, right? But you know, do we take the time to actually map out the value of improving our models and the effort? Because if you think about like do you remember the Netflix? It's like this renowned thing. Netflix put out a Kaggle competition, and you know, to win $1 million, and people made the very complex model to do it. Anyways, it actually got to a point where it plateaued for a really long time and nobody could improve it. And it took, I think, over a year and like many teams and this multiple models to get it to that high accuracy level. And in the end, it wasn't worth it because the model was too complex to even run. So Netflix didn't end up using it. And these are the conversations people need to have is what is it worth to get this X% improvement, right? What is the benefit and what's that cost benefit analysis, right? And we don't have those conversations a lot, or maybe we need to have more of them is, you know, what is good enough, what's an improvement on current state, and what's that worth, and is it worth to invest 6 to 8 months more in research and development to get better? And this is the best part is that when they ask, well, how much better can we get, I don't know, because it's a game of probability. So I could work for 8 months and not get the model better because the data itself doesn't explain enough variability in the outcome for me to extract enough to get you a higher accuracy. That just could also be the outcome. And that's what I think people like software engineering, because if I tell you to make the button blue, you'll make the button blue. You don't say like make the button blue and I say, well, maybe.
Make it bluer.
Yeah.
How much bluer can we make that button? Because it's not blue enough, but maybe we make it like 5% more bluer. Yeah, it doesn't work exactly the same way, does it?
All right. So, Andrea, this was wonderful having you on. We definitely appreciate your insights and expertise, and always John and I love to have interesting people on, and you were very interesting. Would you be okay coming back on with us again sometime?
Sure, would love that. That'd be great. Thank you so much for having me. I had a lot of fun.
Awesome. Well, this was the Unriveted team, and that's a wrap. Thank you.